Hello, let's place dominoes. It's time to solve pips. We've got, as is often the case, an easy by Ian and a medium and hard by Rodolfo. Let's start solving. Okay, what do we have here? We need 3 of something, which will be 4s, it looks like. We need to make 6 twice, and these will need to be bridged because we don't have 2 ways to make 6 in their own dominoes. And what did I say the equivalence is? 4s. So I don't know. I'm not really sure how to start this, but well, I guess I am, because the 3 needs to go there. That's straightforward. I guess we could add up the number of. I mean, the 3 will have 3 4s, so this is equal to 12 plus another 12 from the 2 6s is 24. So 5 plus 7 is 12 plus 9 is 21 plus 4 is 25. So we need a 1 in the void, which means it's the 1 4, so that we can make our 4s. So I mean, it's an easy puzzle. I don't usually bother with stuff like that, but you know what? Today I did. And then these can go in either order because the cages below them are identical. So then we put this in to finish the 6s, and there we go. That's fine. Okay, that was the easy puzzle. Let's move on to medium. Right, we need 2 zeros in the 0 region. We need greater than 1 going into a 9. So the 9 must be at least 3. So we could put 2, 3 in. This would be the sort of lowest way to do both of these. Then we'd need a 6 there, which would have to be this 5, 6. I'll just try this. We'll see if it works. We need... actually, this is a little bit tricky. Actually, this doesn't work. Does it? I don't think it does. Because we don't have enough 1s to make the 2. Yeah, this doesn't work. That's interesting. Because look, I mean, just in theory, if we used we could make 8 with that. We could make 7 with a 3 and a 4. And then we couldn't make the 2. We don't have enough pips. Makes me think I should maybe use the counting method on this as well now, because we have the greater than 1 and too many voids. I won't bother. But that is interesting. So what do I think that means for the 2? That's probably the important region, because the only way we could use the 2 in it would be to have this here, which might work. We would then have to double 0 here, and we'd need to put another 0 up there. The 7 would have to go, no, just, okay. We would need the 8 to be self-contained, which would have to be the double 4. That's the only way to do that. And then the 9 would be 5, 4, or 6, 3. No, it can't be 5, 4, because we need the 4 for the 7. That's the only way to do it, so that 4 goes there. So the 9 would be 6, 3. So it would be this. Yeah, this will work. Yeah, that was interesting. Okay, there we go. A slightly trickier easy and a slightly trickier medium, I think, perhaps. Let's see what that suggests for the hard. Let's try it. Okay, we've got an N in the grid. Wonder how close we are to using all of the alphanumeric characters, at least in the sort of English language alphabet. Right, so we need 3 6s in this 18. That's interesting because it's connected to an equivalence region, so we can only have 1 of these 6s from the 18 pointing into that, which means we'll need a double 6 here, because if we didn't put a double 6 there, then we'd need more than 1 bit of the 18 pointing. Oh wait, no, that's not true. We could put the double 6 here as well. We do need a double 6, but it could go here as well if this equivalence region has its own double that goes here, which it might do. It might be 3s, might be 2s. Right, okay. But we do need a double 6 in the 18. We definitely need that. Actually, we would have needed it anyway because we only have 3 6s. Sorry. So if it were here, that would mean the equivalence region would have to be 4s. Does that even work at all? It doesn't look like it does because we don't have a double 4. So I think what that means is the double 6 needs to go here. And then the 6 4 must go here to point into the 4. So that's fine. Right. So now the equivalence region will be 2s, 3s, only 2s or 3s, because those are the things of which we have 2 in a single domino. So 2s, 3s, and 1 will be a 2 connected to a 1 or a 0, which we have. We have that, and we have it with, we can do it with 3s as well. But then we'll also need a 2 or a 3 connecting to a greater than 2, which, we could do that as well. We could put 3, 4 there. Okay, that's fine. So I don't yet know. But let's look how many zeros we have, actually, because we need 2 down here, 2 up here. So we need 4 zeros at least. How many do we have? Oh, we only have 4. Okay, so the less than 2 cannot be a 0. It must be exactly a 1. So it will be a 1, 2 or a 1, 3, but unfortunately we do have both of those. This less than 2 will also be a 1 because, again, we've used all our zeros. And we've got 2 more. We've got the 4-sized equivalence region and 2 3-sized equivalence regions. We don't have a double 0, so this 0 will point up into something that we have 3 of. And then this 2 will have 2 1s because, again, we've used all our zeros. Do we have a double 1? We don't. So 1 will point into the greater than 4, which might only have one. It does only have one possibility because we've used our 6s. So that's 1, 5. So now we need another 1. How many 1s do we have left? We have 3 1s left. So a 1 cannot be a 3-sized equivalence region. That we know. We can't use the 1, 2. So we'll be using we can't use the 1, 0. So we'll be using a 1, 3 or a 1, 2 up there. It's not helpful because we already are going to have an extra one of those after the 4-sized equivalence regions. So, okay, what about this 0? Pointing to a 1, a 2, or a 5. Oh, no, or a 4. Oh, do we have more zeros than I thought? No, we have 4. That's what I thought. Okay, sorry. 4 seems like the most difficult because if this went here, that doesn't work because we don't have a double 4 up the top there. So either it points across and then we need a double up there, which would have to be. No, we don't have a double that can fit up there, do we? No, we do. Yeah, it could be 0, 2, and then we have double 2. It could be that, or the 0 is pointing down, which would mean it would need to be 0, 1, pointing down. Those are the only ways to do this, I think. So I think this 0 is a 0, 1 or a 0, 2. Is that useful? I don't know. This 4 will be 1, 3 or double 2 in some disposition. Let's go back to this 4-sized region. What were our choices there? 2s or 3s? Should we just try one and see if it works? Let's try putting 2s in there because I think this is more constrained, but I could be wrong. We then need a less than 2 connecting to a 2, so we need a 1, 2. That would have to be that. We then need a greater than 2 connecting to a 2, which could be 2, 3 or 2, 4. That's not hugely useful. Although we have entirely reduced our possibility space for the 1 that goes in the 2 region up there, which now must be 1, 3, because we can't use our 1, 0 because our zeros are all spoken for. So that's that. That means we cannot put a 1, 2 here because we don't have more 2s there. So that is more constrained. It is. I thought it was, and it is. So that means the 0 is pointing down into the with its 1. That's the only way to do that, I believe. So that would go there. What does that tell me? Now we need 2 sets of 3, which will be 3, 3, 3, and I guess 2, 2, 2 still, but the 2 isn't, we don't have it doubled in a domino. Does that mean anything? Oh, we need a greater than 4. I kind of forgot about that. That's been constrained for a while because we haven't had 6s for essentially the whole puzzle. So this goes here, but it actually, I think this is actually true no matter what my other supposition was, because the 5 is connected to a 0, and we can only put zeros in 0 regions. So that does point up for sure, which means we do need a double up here, which makes it 3 in this universe, which is still contingent on those 2's down there. But the 5 bit is correct. Then we need a 3 pointing down, which couldn't be 4. No, we do have enough 4's. We do have enough 4's. Could it be 2's? No, we don't have enough 2's because we still need to use one over there. So this would be 3, 4. Then we would need this 4, 0 pointing down. Then we would need this 0, 2. So we're going to make our 4 out of 2's. Yeah, this will work. And then we put a 2, 4 over here, and we finish our 2, 3, and that was correct. Okay. So that was a bit of a supposition. I was considering the 2's, but the thing is, I find it's always good to start with the most constrained possibility, which I believed to be the 2's, either because it's constrained and you'll prove it wrong, or it's correct, but there will be fewer ways to make it correctly. So you'll end up at either way, you'll either prove it wrong more quickly or end up at the correct answer more quickly. And that's what happened. Okay, well, there we have it. Those were the pips. Back tomorrow. Bye for now.